What's up YouTube? So I've been having an issue with my Cellink B battery that powers my dash cam. When I've been going over bumps and going around corners quite hard, it seems to be disconnecting momentarily. Now you can tell it's doing that, it actually makes a noise when it disconnects, which I'll demonstrate like this, and it's been driving me mad. So I've narrowed down the problem to this cable here. I'm just going to take it out of the car and see if we can actually fix it now. So apologies for the mess, everyone. I do keep meaning to tidy up, but I haven't quite got around to it yet. So the first things first, we just need to open the battery. But as you can see, it's a sealed unit all the way around, and there's not really any place that you can unclip. There's no screws on the back to actually unscrew, so the only way we're going to have to get into this is to pry it open. So I did try prying it from the side, just using a screwdriver. You can use a flat blade or whatever you can get your hands on that's going to get in between, and you might have some success. However, I wasn't able to actually open it from the side because it is really well pressed. So the way that I've done it is, if you just go to the connector, the input connector that you're actually trying to service, you should be able to get a blade between the rubber grommet seal and the case itself. So if you just pry up on there, you'll find that the whole battery snaps apart. So I've already done this, so the case should just lift off. And as you can see on the inside, there's no clips or adhesive or anything like that. So when you want to put this back together, you will need to put some super glue or something similar to seal that back down. So the first thing we're going to do is test the continuity between the connector and the pad, just to see if we've got a break in this cable somewhere. So if you switch to your continuity tester, just any multimeter will do, and place one of the probes on the pad and one onto the connector itself. And if we just wiggle the cable around like we was doing before in the car where it's disconnecting, we should be able to see if there's a break, because the beep will stop beeping. As you can see, there doesn't seem to be any issue there. So we'll switch to the other side of the cable and see if we've got any continuity issues there. So one side on the pad, other side on the other connector, and then we'll just move it around like we did in the car, see if we can recreate the issue. As you can see there, when you bend the wire in a certain angle, the continuity stops and we've got a break. So we found the issue now, and the only way to really resolve this is to desolder this, replace the wire with something new, and then replace this connector as well. As the break could be anywhere in this wire, it's not really worth trying to open up the silicone sheath and fixing it. It's just not worth my time. So next step is to desolder these two connectors, because we're going to replace this wire with something new, and we're going to replace this connector as well. By the way, this is an XT60 connector. So I have received some new XT60 connectors today, so I'm just going to go ahead and desolder this now and replace this section of wire, including the connector at the end. So yeah, these can be had on Amazon or eBay, or you can probably get them imported from China a lot cheaper, but I wanted it fairly quick, so I got it from Amazon. To get your heat shrink tubing and the connectors that we're looking to replace today. So you want to replace the female one on this side, as you can see. Fingers crossed the brand of connector should be the same size, because it is a exact spec and it fits perfectly, so we shouldn't have any issues there. So do be careful when you're buying these connectors. Don't cheap out too much, because some manufacturers are apparently making them super cheap to a point that they don't really make contact all that well. So if yours just slide in and wobble around, just throw them away, get some new ones. It's just not worth the fire risk. So the next step is to actually desolder the pad and lift this wire off. I did try with my small soldering iron to do that, but that wasn't working, so I've switched over to a gas-powered soldering iron. Hopefully that gives that a bit more heat. So we'll just let that heat up and give it a clean off in a second. So always make sure that you're working with a clean tip on the soldering iron, so always have something handy, like a tip cleaner like this one, to do that with. And then just tin the end as well, make sure that's good connectivity, or conductivity should I say. And the next step is just to lift this wire off right now. You see the solder's starting to come away now. Should be able to start lifting this off any second. It's taking a lot of heat to get this going. Could probably do with investing in a bigger tip. There we go. And that's now away. Let's do the same on the other side. There we go. So there's a little few strings remaining on that side there. Let's pull those away real quick. There we go. So we've got the old connector. That's the issue. We're just going to swap this out with similar cable, replace this connector, heat shrink everything, and then we should be good to go. So I believe I've actually found the problem as I was actually getting ready to make a new connector. I was following this wire down just to make sure that I had the right positive end, and I noticed that the connector at the very end actually came off really easily. I don't know if you can see there, but it looks like at the factory the solder didn't make a good contact, and that's the problem that I've been having. So instead of making a new connector and having to replace this rubber grommet, I can actually just reuse the original one and just replace the connector on the end. So it's always best just to make note of which one's the positive and which one's the negative. As you can see on this cable, it's actually just got a white stripe for the positive side, so we know which one to solder into the connector. If yours hasn't got any markings or anything like that, just make sure you tag it with some coloured tape or something, so you know when you're soldering it back together. You definitely don't want to be reversing the polarity on something containing lithium batteries. So let's go ahead and chop the end off the existing connector. And then we just want to strip that back slightly and then solder in to the new connector. And it looks something like that. So now we've got the ends chopped off, we just want to strip this back with some wire strippers. Put your heat shrink tubing over the wires ready, and then solder in this new connector. So I always find these style of wire strippers to be the most convenient, because all you need to do is pop the wire in, snap, and you've got your perfect wire at the end. Do the same to the other side. How easy is that? So twist your wires around at the end, and then you want to make sure you have something like this as well, because it can be super fiddly trying to do this with one hand. So if you just set your wire up in there, and then we're going to put the connector in the end there. And that's just going to hold everything in place whilst we do the soldering. I'd say it's almost, not absolutely impossible, but almost impossible to do this without something to hold it down. So you might find it's easier just to tin the wires first, put some solder on the ends of them, put your flux on this side, and then solder that in, because they should make contact straight away then, and you're not fiddling around with it. So I'm just going to heat the soldering iron up again. It's actually a really good soldering iron, this, from Dremel. I bought it a few years ago, and it's really good for, you know, doing car audio or just generally any electronics outside when you don't have a plug socket. It's actually quite powerful as well in comparison to even my plug-in one. So for jobs where I need a lot of heat, this is my go-to. So I'm just going to put some solder on the ends of these wires. Put some on there. There we go. And that should just make a better connection when we actually come to solder it into the connector. So the next thing you want to do is put some flux on the connector itself. For a long time I never used flux, and I just used flux containing solder. But since using flux, I've realised the error of my ways, and this is much, much better. So make sure you've got your heat shrink tubing chopped to size. We probably want about, let's say about that much. One of the black. And one of the red as well. Pop those back down. Let's put those over the wires that we're actually going to solder in. So put the red over the positive side, black over the negative side. And then, a bit of advice as well actually, when you put the heat shrink on, slide it all the way to the end, because you don't want the heat of the soldering iron to actually shrink the tubing whilst you're working on it. These solder connections now. Make sure you make a good connection with the wire and the connector itself. That should be good enough. Let's turn this around and do the other side. That should be perfect. So I'm just going to remove it from the helping hands and just inspect it and see if we've got a good connection. So that looks good enough. It's not the best soldering in the world, but I only do it occasionally, so it's good enough for me. And it's certainly better than the connector that we took off before. So before we put the heat shrink on, I'm just going to check the continuity between both ends on the wire to the connector. So first we'll check this side. That seems good. Check this side. That also seems good. Perfect. Just want to pop the heat shrink over now. Make sure you push it as far as it will go into the connector. That's good enough. And then you can either use a heat gun, or you can use like the end of your soldering iron or a lighter or something like that. I'm just going to use a heat gun because I have one to hand. As you can see, that's perfectly shrinked on. So it certainly helps to have a heat gun, because as you can see, it makes a really clean shrink. If you use a lighter, you can actually put burn marks on there, and if you use the end of your soldering iron, you can do the same as well. So the only thing remaining now that we have a connector on the end, is just to solder it back onto the board. And if you remember from when we disconnected it, the positive was at the bottom over here and the negative was at the top. It's best to just do it one wire at a time. Once you've got one wire on there, it'll just anchor itself, and then you can position the next one. So I'm just going to do the same for the other side. So that's both the positive and the negative soldered in. I'm not really too fussed about the way it looks. I mean, I only do this occasionally. The guys that do these are doing them day in, day out. But as long as it functions correctly, which it will do, that's good enough for me. So I'm just going to put the case back on. I'm just going to use super glue to actually glue this back on. It comes from the factory sealed around the seam, so there's not really any way to put that back together without gluing it back. So I've just used super glue to seal around the outside of the case. Again, it's not the neatest job in the world, but it doesn't have to be super neat. It's purely a functional device that sits under my driver's seat. So go ahead and pop the case back on and we should be good. And there we go, good as new. So I'm just going to pop this back in the car now and hopefully that should fix everything. So we're back in the car, everything's hooked up, the battery's plugged in, and everything seems to be working as expected. So yeah, I'm quite happy with that. One less thing to worry about.